Glad to be here. Good morning, everyone. Just a real quick slide briefly who we are. So NGS, we're been around since 2009. We're a software engineering firm based in Charleston, South Carolina. We focus on services contracts for defense customers and primarily in like the special operations domain. We've worked with the open source geospatial technology stack, kind of the OSGeo stack for a long time, GeoServer, PostGIS, GDAL, MapStore, and of course CesiumJS. And so a couple of years ago, we kind of decided to create a product branding called CoreSpatial, basically taking in all that software, putting a hardened security layer around it and an enterprise deployment package. And then we sell that as a subscription with support. So what I'm going to talk to you about today is some of our kind of primary challenges we've done in the application development stack that we have worked on over the years and how that kind of ties into Cesium. And then, of course, kind of at the end, I'll wrap up with our recent integration of Cesium Ion on-prem into our product stack. So this is kind of representative of like three major areas of problem sets that we deal with on a day-to-day. So we're typically building common operating pictures for military use cases around mission planning, situational awareness, and logistics and things like that. So we're typically dealing with a lot of real-time streaming data, vessels and aircraft and ISR assets and things like that. Moving around on the map. We also deal with a lot of data kind of across the enterprise. So we're usually integrating with other systems. It's a pretty complex enterprise, so you're never just the only tool out there, right? You're having to pull data in from other data sources, other systems. And so that interoperability layer with OGC is really important, and I'll talk about some of the advanced use cases we have there. And then, of course, our 3D integration, and this is kind of more recently, we've been getting a lot into the 3D, obviously bringing in point cloud data and visualizing those high quality 3D tiles in our applications. And then another kind of aspect just overall here is that this CoreSpatial platform is really built to be kind of like a GIS in a box. It can be deployed in like a tactical environment or like an air gap network, a customer government network. And so we need all of these systems to kind of work disconnected from the internet, disconnected from larger enterprise systems, have their own identity management, have their own resources, and of course being able to process that data as well is really critical. That's where kind of the Cesium Ion on-prem comes in as well. So first topic, talking about tracks, basically putting a lot of track data on the map at scale. So anyone who's ever coded in this kind of with real-time streaming data knows that you get to about 1,000 or 2,000 tracks, and if you're pushing real-time data and you're basically just moving entities one by one as the updates come in, you're going to kind of run into a performance issues with the rendering. So the fix for that is really to kind of decouple the rendering cycles from the data updates, the flow of the data coming into the application. And I'm going to kind of deep dive, our architecture and what we've built for our track service and how we do that to kind of address those issues. And then another big aspect of what we do has to do with basically cartography, like showing the proper level of detail for what the user is looking at the current time. So, with a kind of realistic goal of 10,000, moving things on a map and have it actually have a smooth frame rate. So this is kind of at a high level our tracks pipeline. So just starting on the left are external services like ADSP or AIS or various tactical systems, ISR systems on the network. And then kind of the message broker, which is really just reading from the network, those TCP connections or UDP connections that are reading that real-time data and kind of absorbing that bursty or overwhelming nature of how that data kind of comes in. Every system's a little bit different. They behave differently. They send data differently. So you're parsing the data, kind of putting that into a a common format, and then passing on to our track service, which is really where a lot of the intelligence is. So this is where, basically those WebSocket backends that are serving the client, and they're dealing with, indexing and filtering the data, culling, old records and batching those updates appropriately to the client, so that way you're not overloading the client. And of course, your clients are talking to that track service as well, right? Like as users are moving around, interacting with the data and the application, the track service is understanding that and properly sending the data that it needs to. So less thinking on the client and more on that track service middleware layer. This is a detailed diagram. I'm not going to dive into all this, but I'd be happy to talk about this more if people are interested later. This is kind of a full diagram. We have kind of in the middle tier there, so working the top down, the external feeds down to the broker services, the track service, and then on down to the client. And we show like a few of these components. We're using Redis and Tile38 in the middleware for kind of that real-time caching and streaming, and then a persistence layer there as well with Postgres, PostGIS, or DuckDB. Quick connections in between for that like high speed movement and flow control that gets us. So. And this is just a little video of putting those 10,000 tracks on the map. This is our just like a test harness that we have that we test with. So basically developing that RTS infrastructure on the back end. We have basically test harness here that just showing how we as the user zooms around and moves the map, that track service is picking that up and properly showing the level of detail. So we started out kind of with a high level view, a heat map. And then as we drill down, we get the full entities. And as we click on them and interact with them, we get the full attribution as well. So the next area that I want to talk about is the OGC interop. So this is really just being able to eat lots of different kinds of data, right, from around the enterprise. So most people are probably aware, we've been talking a lot about OGC protocols in here. So the WMS, WFS, OGC features, all of those have kind of a Cesium primitive that they map to cleanly. However, there is quite a bit more to implementing OGC than just using these primitives and pulling in data. I'm going to move on to the next slide because that's kind of where the detail is. This view is really just showing that we've kind of mixed now together those real-time tracks with some WMS overlays using imagery and some background canvas there, and then some features as well there, boxes that have been drawn on the map. And so I guess the point I want to make here is about kind of implementing the full protocol. So you've got your catalog services that you use in OGC to bring those layers in, and then you can render them with but basically, if it's a WMS, it's already rendered. If it's a WFS or a feature, it needs to be rendered in the client. But you can utilize those same constructs between both the style sheets that come with those layers. So yeah, so server-side, the server-side symbology that GeoServer provides with SLD, that's going to get you, this kind of consistent authoring, whether it's your own application eating that data or it's some, external party that's pulling in that data. You're going to get that consistent symbology. And then going back to level of detail, the scale-aware rendering or scale-dependent rules in those style sheets, and being able to generalize features at a higher zoom level and then give the full resolution as you zoom in. That's a very important part of the kind of the authoring process that goes into those layers. Clicking to identify, so not loading up the client with all that feature data and attribution just for visualization, but when they click or interact with the data, then you can actually go and pull the data through get feature info or get features. And then the time dimension, this is kind of like an underutilized part of the protocol as well. We do a lot with trying to visualize data over the last 7 days or last 30 days. Somebody wants to get a trend analysis of where these tracks have been moving, through the strait or what have you. And so being able to utilize time dimensions in the data, so you can kind of get that draggable timeline slider in the application. So these are some of the things we bring into the application. Okay, so moving on to the kind of the third part, this is the Cesium Ion integration. So this is just showing really there's two modes here. I mean, everyone kind of knows the cloud SaaS hosted Ion service. The self-hosted really serves the same API, so they're API identical between the two there. Obviously, the big difference is one you can host on your own server. We've built basically, so CoreSpatial Portal is our main user-facing application in CoreSpatial. It's where you author maps, it's where you share maps, you analyze data, geoprocessing tools, table views. It's even got like dashboarding capabilities. So it's also got a plugin architecture. We built the Cesium Ion plugin for CoreSpatial, and that's going to integrate with both the cloud and the self-hosted API. To bring the ability to basically have users upload data, process that data on the server, and then draw those 3D renderings. And I have a little demo. See if I can explode that out. Yeah, there we go. So this is just kind of taken through the process of an analyst who's captured some drone footage, and they're just kind of looking at it here, and then they're going to move into Portal and upload that data. This is the Portal interface. You kind of have your layer list on the left-hand side there. There's the plugin, and it's basically a drop zone. Just going to drop your file data in there. We analyze the data, so as soon as that's provided, we can read the metadata, we can display it. We can kind of give the user like a warm and fuzzy that they've actually uploaded the correct data. There's some warnings there about how the photogrammetry principles work, and it's showing us obviously where it is on the map, and some of the attributes from those EXIF tags. And then just going through the upload here. Won't bore you with all that, but watching the job process, and then ultimately with those finished 3D tiles, then bringing those into the portal. And I don't have a full loop on that, so we kind of flipped over to the Cesium Ion there, which is where the data will also show up, of course. But that's that, and this is kind of what a full 3D view would look like with some tracks on there. And this is just pointing at the Cesium hosted view, but just to give you the idea of what that would look like. All right, and so I want to kind of finish with this last piece, just kind of bring it back together. The on-prem or air-gapped solution with CoreSpatial here, and with Cesium Ion self-hosted, we have the ability to have that full GIS capability, even with real-time streaming data from a local network, as well as collected data from your drones or your LiDAR sensors, and processing that data and then creating those 3D tiles all within that enclave. So GIS in a box plus 3D. And so I'm wrapping a little fast, but we'll leave room for questions. Just to kind of recap, so we just wanted to talk about the tracks the way we do, the tracks architecture, really decoupling that renderer from the render cycles from the data flows and the update cycles, and then the OGC interop and how we bring that data into the Cesium views, using kind of those more advanced techniques and implementing the full OGC protocol to leverage those features. And then of course the Cesium Ion cloud grade 3D in disconnected form. So, thank you.
Thanks, Jason. Pretty amazing to see all that stuff, and especially bringing the GIS and the 3D geospatial stuff together with the tracks and everything is pretty cool. So I will. We have a few minutes here for some questions. If anybody has any questions for Jason while I was up here. Luke.
Cool, thank you. Yeah, awesome use case and like how you put all the pieces together is really cool, especially the OGC stuff. It's great. Yeah, it's great to see kind of a demonstration of tying that in so cleanly. Yeah, like what are your what's your biggest requested feature, or like like biggest highlights of like future direction and stuff that you'd like to see?
Yeah, that's a good question. I mean, right now, 3D is absolutely exploding. So we're seeing more and more people wanting to, bring their own data and process it. That's kind of the premise behind, obviously the Ion integration. But I would say, like, if I go back over the years, kind of the most requested feature is it's about those tracks, the moving assets, the real-time streaming. There's just more and more sensors out there every day, and more data formats to deal with, and everything moving around kind of in real time to get that on the map has probably been, there's more work that we've done, or custom development that we've done under that in that domain area than anything else. So it's the performance, right? Because it's easy to put it in there, but to make it actually work in a real system, right? These are people who are using this to do really important missions, and so it's not a toy. It's something that has to work and it can't break. So, sure.
Yeah, is it so yeah, seeing the tracks and stuff is about real time? Is it about like kind of like recent time, like the last 28, 40-hour window, or is it like a whole history? Yeah, just curious about that. Yeah, when we're talking about time, like which is the most important? Yeah.
There's a little bit of a mix now, especially with like so much of the maritime stuff. So like there's providers out there like Kepler, they're pulling in AIS and then doing some post processing to it, and they're putting out stuff that's like a little bit late. These are like, they're serving a lot of like commercial customers that are doing things with like, they want to know like where the oil is, right, and trading and things like that. So they don't need real time, but like typically in our domain with our military customers, it is really about like that near real time. I really need to know exactly where it is, and he's doing some kind of mission out there. So the attribution as well, right, like getting all of that information into the COP is important. Yeah, and then real time is not, some people, real time is a real thing, right? Like this is definitely near real time. It's not.
Cool. Another question over here for you, Jason.
Thanks. Hi. I was just curious. I was looking at the graph you posted in the other slide. What were some of the optimizations that you guys made to increase the render speed? Was it primarily back-end changes, or was it front-end changes? I see you guys are using primitives instead of Cesium entities. Did you originally start with entities, or did you switch to primitives and stuff like that?
Yeah, that's great. Primitives for sure, because you've got to. So, I talked a lot about like decoupling that render cycle from the data, right? So you're controlling the data as it's coming in from that track service, but really you're not re-rendering every time somebody changes, right? You're re-rendering on a schedule, like every 100 milliseconds or 200 milliseconds. So like if I was going to do like the biggest thing you could probably do, like now, if you're working, if you have a similar problem right now and you wanted to like do this on Monday, I would put a rendering cycle control. It's basically a throttle into place, right? That's going to allow you to control your frame rate and your updates. So, you don't need like milliseconds in between every little update, and that's just going to make the graphics layer thrash. So on the front end, that's I'd say like the biggest part, but it also goes back like that back end or middleware service is just as important, because it's throttling the data as it's coming to you and giving you the right data for what you need. Those users are basically zooming around, they're looking all over the place, they're filtering, they're interested in maybe just 10 tracks, or they're interested in like a whole feed, or maybe they just want like the whole view. So bringing them the data that is relevant to their current view is also just as important.
Cool. Any other questions? Jason, you had 2 and 10,000 tracks. Like, how did you figure out 10,000? What happens after the 10,000?
Yeah, I think 10,000 is kind of like, just over the years of working with GIS data, right? Like, can you make any sense of 10,000 things on a map, on a screen? Usually at that point, especially when you're just talking about points, like little icon points, you usually are talking about overlap, at a degree where it's not even a good view, right? So I go back to like my GIS training days of like, our cartographer's hat. Like, what's a good map? What's a meaningful map here? Just putting like tons of stuff on there at some point just runs out of usefulness. So, that kind of going back to the way we throttle that data through the track service is really important, the level of detail.
Cool. Yeah, definitely. My background's in cartography too. I wanted to separate out all those points and not have them overlap, because otherwise it doesn't make sense, right? So yeah.
It's cool to be able to just like juice it up for programming prowess and make it really tight and nice. But obviously that's not that useful in the real world.
Still got to be the useful part of it too, right? So
yeah.
Cool. Well, Jason, round of applause for Jason. Thanks again.
Thank you.